Assalamualaikum and greetings. We are from Group 10. Today, we would like to present our design study project entitled Chili Padi Picking Robot. First and foremost, my name is AFEEQ HAIKAL bin AZHAR B0518101335. On the first part of the project, we have proposed a design for the Chili Padi Picking Robot. However, we found that the old design has several flaws which can further be improved. Hence, we have designed a new 3D model for the Chili Padi Picking Robot, first adhering to the ergonomic design guideline. The description for the new 3D model of the Chili Padi Picking Robot is that it is cube-like a shape, aluminium alloy structure, 1.73 meter in height and 1.1 meter in length. The chili storage has been repositioned as well as the controller box. Few adjustments has been made on the handlebar with an additional motor actuator. Moving on to the next part, this is the 3D model of the new design. As you can see, the new 3D design consists of a delta robot, windshield, controller box, motorized wheel, chili storage, handle, and solar panel. Next is the comparison of the 3D model. On the left side is the old 3D model for the Chili Padi Picking Robot, and while on the right side is the new 3D model of the robot. From the illustration, we can observe that few adjustments has been made to further improve the design of the Chili Padi Picking Robot. Here is a more detailed comparison between the old and the new 3D model. In the structure aspect, the old structure is shaped like a C consisting of a single pillar, while the new design is shaped like a cube with an opening, includes extra pillar for extra stability. As for the handle part, it is rounded in shape with slight bending for the old design, while the new design have rectangular shaped handle with additional pressure sensor for the motorized wheel. Next, moving on to the wheel, the new design consists of motorized wheel to ease user and reduce force exerted by user during using the robot. As for the controller box, the old design has small controller box located at the bottom of the robot. For the new design, we have improved the controller box space by enlarging it and placing it on the side of the robot. It also comes with a transparent lid, which is maintenance process. And lastly, for the chili storage compartment, the old design placed the compartment at the rear and bottom part of the robot. This will need user to bend to collect chili from the compartment. For the new design, we have placed the chili storage compartment at the side of the robot with a hinge which can ease user to collect them. In this section is the comparison between the human stature and the height of the robot. We can see that the robot is slightly higher compared to the human stature by 10 centimeters.
In designing, we applied three of the applications of human factor and ergonomics or HFE, which are anthropometry, persona, and user interface. The final design of the project is based on these considerations and applications. My name is Farez Amsyar Zulkifli, and I will talk about anthropometry. Anthropometry is a study of measurement of human individual, and anthropometry study is used to study and understand the variation of human physical. For this project, the anthropometry study is based on these criteria of working angle. The functional arc of the elbow flexion is between 30 to 130 degrees. This could be translated that the elbow flexion should not exceed 130 degrees. The optimum 70 arc shows the optimal angle of working elbow flexion is in range of 50 to 120 degrees. Hence, we said that the elbow flexion should not be over 120 for all the targeted users, no matter of their physique. The abduction of the arm, this is the abduction of the arm, should be near 0, and the arm flexion should be set at a maximum of 10 degrees. The calculation is based on this data of the overall Malaysian adults of men and women. The Z score that will be used is the 5 percentile, and the mean and standard deviation that we use are the elbow height, forearm hand length, and shoulder elbow length. These are the calculations that are made to get the position of the handle. The calculation is done with the help of trigonometric concept so that we can get the distance between the elbow height or p value to the distance where the flexion is present. From the calculation, we get that the handle position should be at 1197.25 mm above the ground to accommodate the 95% of Malaysia population. The 5th to 95th percentile of population can operate the handle in the range of optimal working angle.
Assalamualaikum, my name is MOHAMAD IZHARUDDIN and I will talk about the persona. Persona is a representative of a target real end user to be used as an anchor to design and evaluate the design. Persona also can minimize bias through the normal tendency behavior of self-referencing. And persona also can based on typical behavior pattern and be very specific and detailed. The first persona is about someone who has a potential buyer to buy this product. And based on the persona above, persona 1, which is Mr. Amsyar, is one of the potential buyer because he was the owner of the farm and the businessman. Besides that, based on Mr. Amsyar's goals, he wants to further his farm and looking various initiatives and ways to develop his farm. While persona 2, which is Mr. Shafi'i, his persona show that he has a potential to use this product, which is potential user, because of his profession is farmer. Using these two persona, we can know that can help designer to explore in different way the product may be used by different people in different settings.
I will continue explaining the user interface consideration. First, user interface in ergonomic emphasizes on the product usability, which provide comfort for the user during product usage, thus give better perception toward the product. There are three aspects for user interface design. First is affordance, next is mapping, and lastly is constraint. For the affordance aspect, it is used to ease users to understand how to operate the product. As an example, a rounded door knob is mean that user can twist the door knob to operate it. For our project, our affordance is at the handlebar, which indicates user that the robot can be moved. And next is the gap between the handlebar that signifies user the handlebar can be gripped by the user during using the robot. For the next aspect is mapping. It can be defined as the relationship between controls and their movement or effects. As an example, mapping is the wording on a flip switch to indicate the on and off outcome of the switch. At the handle of the robot, an engraved arrow design on the handle represents the forward and backward motion when it is pulled or pushed that activates the motor due to pressure being applied at the sensor. And lastly, in the constraint aspect, there are three types of constraint. This aspect is important to apply in the design so that user is more directed for specific action during using the product.
For the form and function, the form in this product have 6 forms, which is handle, structure, caster wheel, chili storage, gripper, and electronic component. The function of a handle is user to hold and operate the product, which is the shape is rectangular and it have additional pressure sensor actuator for the motorized wheel to ensure that the user can grab the handle properly and tightly. for the structure need to belong to meet the height specification, and along with the cross joint and provide better support. The material for the structure is aluminium, which is similar to the bone structure of the robot because due its the lightweight characteristic. For the caster wheel, the cylindrical shape wheel design where the curve is contact to the ground. The new design of the wheel was add motorized wheel with tread. The function is to minimize the force exerted by the user during the process. For the chili storage, the design in hollow box shape, which the function is to store and harvest chilies. The storage placed at the side of the robot equipped with a hinge which allow user to collect chili by unlocking the hinge and collecting them easily. For the form gripper is to pick the chili from the tree. Design the hand like a claw is to hold, pick and put the harvest into the chili storage. And lastly, for the electronic component, to store the electronic part of the robot. And the design is the near to control board at the side of the robot.
Now we move to the task analysis. Task analysis is a method in identifying and studying the tasks that the user needs to perform in order to operate and work the system. The method usually covers the main task and all the subtasks to reach the goals. And the analysis will break the main task into the sequence or smaller steps or action which are the subtasks. From the figure, our task analysis consists of three main tasks which are operating, maintenance and collect chili. Operating has three subtasks which are switch on or off the wheels lock, turn on the robot and push or pull the handle. For the maintenance, there's only one subtask which is open controller box compartment lid. And for the collect chili, it has three subtasks which are push trolley or cart beneath the robot, open storage hinge and take out the trolley or cart. Then the interaction components between existing versus improved design. For the existing design, to move the robot, the user must grab the handle and push and pull it manually to change the direction or move it forward or backward. It requires the user to reverse and rotate every time to position the robot beside the tree. This is counted in the improved where the user does not need to use the force manually because the handle is equipped with a sensor and motorized. So the user just need to grab the handle and push a slight force to make the robot move. Also, the flexion of the arm and elbow while working the handle is in a good position. Then the maintenance. In the existing design, the user need to bow down to perform the maintenance on the machine. And the user may hit their head to the bone structure while working on it. This is countered in the improved design where the user can utilize a stool or chair and sit on it and perform the maintenance on the compartment box. The user does not need to bow down or look up too much in this improved design. Also, the flexion of arm and elbow in this improved design is in a good posture. And lastly, to collect the chili, from the existing design, the user needs to put the bag into the compartment box and use the robot, and after the picking session, take out the plastic bag. The position makes it difficult for the user to take out the chili bag as the user needs to spread their arm to take out the chili bag and the bone structure is interfering. The user also may hit their head to the bone structure when getting up, and the user needs to bend down to take out the bag. For the improved design, the user just needs to open the hinge at the bottom of the chili storage compartment and let the chili drop into the cart. Also, the user does not need to bend or anything, and the arms and elbow flexion also in a good posture.
I will talk about the summary or conclusion. The improved design is believed to be more efficient in design productivity and ergonomically. Also, the position of the electronic compartment and chili storage will also relocate to reduce the awkward posture (ERF) during the maintenance and collecting chili. This new design does not require the user to rechange to exchange tree one by one. but instead row by row. Lastly, this new bond structure also eliminates the issue where the user may hit their head and when getting up during the maintenance and collecting chilli season.